Since we are done with our part 1, now let's go with part 2. Our part 2 is all about linear differential equation. So our problem is number 6 of page 35. So here we need to find the general solution of the equation y prime times the quantity of 1 minus x squared plus xy equals to x. So just like in separable differential equation, we also need to undergo several steps in solving linear differential equation. For step 1, we need to rearrange the equation into the form of dy over dx plus p of x times y equals to q of x, since this is the conventional form of linear differential equation. Since our problem is not expressed to its conventional form, we need to multiply it by 1 over the quantity of 1 minus x squared, so that the quantity here will be cancelled. So we are left with y prime plus x over 1 minus x squared times y equals to 2x over the quantity of 1 minus x squared. Since y prime is equals to dy dx, and having this equation, we already solved step 1. So here we already have the conventional form of our linear differential equation. And this x over to the quantity of 1 minus x squared is our px. We will need this to solve for our integrating factor, which is in step 2. So in step 2, we need to find the integrating factor through the formula of b equals to e to the integral of px dx. So by substitution, our px is equals to x over 1 minus x squared, which we get from our step 1. So for easy integration, we let u equals to 1 minus x squared, and following this solution, we obtain the value of b equals 1 over the quantity of 1 minus x squared raised to the power of 1/2. Now we're done with the integrating factor, step 2. So now let's go to step 3. So in step 3, we need to multiply the integration factor with the standard equation in order for us to get the general solution. So in here, we multiply our integrating factor, which is 1 over to the quantity of 1 minus x squared raised to the power of 1/2, to our standard equation that we obtained in step 1. So in step 4, we need to integrate both sides. So in here, so this is the standard equation. Standard form rather of step 4. So in here, for us to integrate this easily, we let m equals to 1 minus x squared, and following this solution, we obtained this. So by integrating both sides, we have y times 1 over the quantity of 1 minus x squared raised to the power of 1/2, and the integral of 1 over m raised to the power of 3/2. So we need to express this with y on the left side and all the other terms on the right side. So with this, we come up with a general solution of y equals to 2 plus the quantity of 1 minus x squared, quantity raised to the power of 1/2 plus c. So since we're not given of, or we're not given with a condition, so we do not need to solve the particular solution. So this is the final answer for our problem in linear differential equation. So now let's go to the Clairaut equation. So please take note, please remember the 4 steps. First is to rearrange it into the conventional form. Step 2 is to find the integrating factor. Step 3 is to multiply the integrating factor with the standard equation, and step 4 is to integrate both sides so that you will get the general equation. And if a condition is given, you need to substitute the value of C to the general solution so that you will get the particular solution. So that's all for part 2. So now let's go to part 3.